Essay 5.9 Kinematics. So in today's video, we will be discussing the kinematics in calculus. So essay 5.9 of the IB Maths AA curriculum is the study of the dimensional movement. So we are studying displacement, velocity, and acceleration. So displacement that we are talking here or discussing here is the position in relation to the origin, and velocity is a speed but with a direction, and it can be negative and acceleration. So the notation S, we use it for the displacement. Notation V, we use it for velocity. Notation A, we use it for acceleration. So to calculate the velocity from the displacement, we have to differentiate it. We have to differentiate the displacement. To calculate the acceleration from the velocity, we have to do differentiation. That means to calculate the acceleration from the displacement, we have to do second derivative. Okay, so differentiation here. Another differentiation. And differentiation again. If I'm using the notations, it's going to look like ds over dt, dv over dt, or d squared s over dt, right? And if we are trying to calculate the velocity from the acceleration, we need to do integration. So it means to calculate it from the acceleration, we have to do integration. And if we want to calculate the displacement from the velocity, we have to integrate it again. So it means we have to do something like integration velocity, and this is equal to displacement plus c, because we're doing integration. And integration here again, right? Same thing for acceleration. If we are trying to calculate the velocity from the acceleration, we need to integrate the acceleration in terms of t. Then we get b of t plus c. Then let's try to apply this concept with an example. So example number 1, we have a quadcopter that is 1,000 meters high at t equals 0. And velocity is minus 10t. So question A, we need to find A of the t, right? So we can calculate the acceleration from velocity by differentiating it, right? By using the chart, we know that to calculate the acceleration, we have to differentiate the velocity. So we do dv over dt, right? Then this is equals to negative 10 meter per second square, and this is equal to acceleration. Question B, we need to show that s of 10 is equal to 500. So it means step 1 to solve this question is the finding displacement function, right? So to find the displacement function, we need to integrate the velocity to find the displacement. So means we have to do integration v of t in terms of t, right? And this is equal to displacement plus c. So when you integrate the velocity function in terms of t, this is same as negative 10 times t to power 1 plus 1 over u power 2, right? And it's plus c. And we can say negative 5 times t squared plus c is our displacement function. However, we need to find that last c part, right? So we have to use the given information to find the c value. So when t value is equal to 0, we know that displacement is 1,000 meters. So we can do s of t, or s of 0, is equal to negative 5 0 squared plus c equals 1,000. That means the c value is 1,000. Okay. Now, then using this information, we can say that the displacement has function of minus 5 times t squared plus 1000, right? Then the last step, so this was the step 2 of finding C value, right? Then step 3, we need to show that S of the 10 is equal to 500. So to do that, what we need to do is we simply have to substitute 10 equal to t. So we get minus 500 plus 1000, which is equal to 500. So we have shown that the S of 10 is equal to 500. Okay, so let's talk about where to use the kinematics. Okay, so to use kinematics so we often use the kinematic concepts in the real life applications, such as calculating the distance traveled. Okay, so distance traveled is closely linked to the displacement. So displacement is S of t, right? And we will be able to integrate the velocity to help us. So means we have to integrate the velocity in terms of t to find the distance traveled. However, distance traveled takes into account all changes in displacement, even negative changes going backward. So we always have to find the range. Okay, so to calculate the distance traveled, we use this formula. However, this formula is not really included in your formula booklet. So it's better if you understand this formula and remembers it. Okay, so before doing questions like example number 2, let's apply this concept into actual IB question. So here I have IB question, specimen paper, and it's paper 2 exam, so means we can use GDC, right? So the question says that the displacement in centimeters of the particle from the origin O at the time t second is given by S of t equals to t squared cosine t plus 2t sine t. Okay, and t value is between 0 and 5. Okay, so question A, we need to find the maximum distance of the particle from the origin O. So we already know that the displacement refers to a position that's like in relation to the origin, right? So to find the maximum distance of the particle from the origin, what we need to do is we can simply substitute this function S of t into your GDC. So using the y equal tab on your GDC, you're going to type in the S of t into the first equation. Okay, so instead of t, you can use the x value, so x squared times cosine x plus 2x sine x. Make sure you use the window tab. So I'm suggesting you to change the window size of the x value to like 0 to 5. So minimum is 0 and 5 is maximum. And I don't think you don't have to change the y value, y range. So once you've done that, you're actually going to have graph like this between 0 and 5. Okay, since we are just trying to find the distance from the origin to where the particle is presented, or between the x range between the 0 and 5, t range between 0 and 5, what we need to do is we either have to find the maximum or minimum point, okay, and figure out whether in distance wise maximum is further or the minimum is further. And when you look at this graph, you can clearly see that the minimum point is further from the origin. So we need to find the coordinates of the local minimum. So you can use the minimum function tab on your GDC to calculate it. Then you can say that, okay, we get S value equals negative 16.513. So means the maximum distance is 16.5 centimeter. Okay. Then question B, we need to find the acceleration of the particle at the instant it first changes direction. So question B, we need to find the acceleration of the particle at the instant it first changes direction. So when you see the word first changes direction, it's referring to the turning point. And we need to find this turning point to find the acceleration points. Okay, so to find the turning point, that means we need to differentiate the s of t first, right? In order to differentiate the s of t, what I'm going to do is, instead of showing you the GDC, how the GDC works, I'm going to give you the keystrokes to follow it, okay? So what you can do is, you first have to place your cursor in Y2 of Y equals tab on your GDC, okay? So once you've done that, you're going to click on the Math tab on your GDC and go to 8 and Derive tab, okay? So once you've done that on your Y2, you will get something like this. So d over d square, bracket, square, close the bracket, bar, square equals square. You will get this template on your Y2 parts, okay? Then you're going to place x on the first square, and you're going to identify y1 on inside of your brackets and x. And once you've done that, click on enter. Then you will see your second derivative function graph on your screen. Okay. Then, since we know that we have our turning points when the first derivative is equal to 0, what you need to do is you need to find the first, the x-intercept on the graph of the first derivative, or the first maximum on the graph of the original function. So I'm going to write it here. So to find the turning point, value of the turning points, you have to find the first maximum point on the graph of the original function, or the first x-intercept. We know that x is same as t, right? X-intercept on the graph of the first derivative, okay, of the s of t. Then you will get t value equals 1.51986. So we already plugged in the original function into y1, right? And we know we have calculated the first derivative of the s of t in y2. Now we need to find the acceleration of the particle at the instant it first changes direction. So we already calculated the t value or when it changed the direction as 1.51986. Then we need to find the acceleration value. So to find the acceleration, okay, value, we need to first find the function, the equation of the acceleration. So original equation of displacement, we differentiated. So we differentiated the s of t to find the b of t, or s of t, right? Then to find the acceleration, we need to differentiate this s of t again. So we need to find the second derivative of the displacement, or we need to find the first differentiation of the velocity, right? But however, we already calculated the first derivative of the differentiation on your Y2 tab of GDC. We can calculate the second derivative of the displacement on your Y3 using the exactly same method that we just used, okay? So we can do on Y3, place the cursor, right? And use mathematics 8 and derive to identify the template, d over d square bracket, what bracket, you will definitely going to get square, right? And then bar square equals square. And you're going to place x on your first square, and this time you're going to place y2 instead of y1 because we are differentiating the equation on the y2, right? Or the first derivative of s, and we're going to place x on the last square. Once you've done that, you will see another graph on your GDC. Okay, you can always find your acceleration value from your graphed window. However, the best way of doing it is using your calculator screen. Okay, so on your calculator screen, you're going to identify y3. Okay, and when you identify your y3, you will have bracket like this. Okay, then you're going to say, okay, so why I'm using y3? Because y3 is your acceleration function, right? So y3 bracket, and we already calculated t value as 1.51986, right? So we are trying to calculate the acceleration value on 1.51983. So we just substitute this value here, 986. Then you will get your acceleration value when t is equal to 1.51 as negative 8.92. So your acceleration value is negative 8.92 centimeter s square. Okay.